So logarithms are another way to write this relationship, which we will call an exponential. 2 to the third equals 8 is the same thing as saying the logarithm base 2 of 8 equals 3, right? In this exponential, the 2 is called the base. In the logarithm, it's a little subscript. It's written a little smaller and a little bit lower right after the logarithm. That is also called the base. So the base of the logarithm is the base of the exponential. Now, the base is being raised to a power here, which is 3. The logarithm equals that power. In fact, the logarithm equals an exponent. And that's the thing. Logarithms are exponents. That's what they are. Generally, you look at a logarithm like this. If we didn't have the 3 on the other side, we would say, what power do I raise 2 to get 8? Basically saying, what would the exponent of 2 be in order to get 8 as a result? 3. What would the exponent of 4 be in order to get 16? 2. And what would well, that one doesn't really work the same way, but in every case, you can see here the base of the logarithm or the exponential is the same as the base of the logarithm. The exponent is what the logarithm equals. Right? The right-hand side, that becomes the argument of the logarithm. This is just the most general form. It's kind of like we're taking an exponential and we're making a logarithm. The only thing that's missing from the exponential is we don't have the a. We're saying, let's like a equals 1. B to the x equals y is the same thing as saying log base b of y equals x. So logarithms were created by John Napier. They were invented, not discovered. Definitely a man-made creation. In order to simplify the process of multiplication. In those days, telescopes had just been invented. They were starting to study a lot about the Earth and the Sun and the orbit and all that kind of stuff, where the numbers are really, really big. And their ability to do any kind of calculations, the area that's swept out by the orbit around the sun or anything like that, it's very difficult because in those, without a calculator, without a computer, without even electricity, that was very hard to make calculations with big numbers. The principle behind logarithms is this. These are two pretty big, although simple numbers. 10,000 times 100,000. If I write this 10,000 as 10 to the 4th, and the 100,000 as 10 to the 5th, then I can use the properties of exponents, because when the base is the same and you're multiplying, then you add the exponents, properties of exponents. So that is 10 to the 9th. And then I can go, all right, well, now that I know that it's 9 and I figured that out by addition, then I can back out. That would have been 1 billion. Okay, so that's what they did. They made tables of logarithms, tables of the exponents you would raise a common base to in order to equal, tables and tables of all different numbers. And they use a lot of powers of 10, scientific notation kind of stuff to do it. And they were able to do a lot of calculations that before that just weren't possible. And discover things like that, we're going around the sun, but it's not a circular orbit. It would look circular just to the naked eye. If you could see, somebody depicted on a piece of paper, it would look pretty close to being a perfect circle. But it's not. It's a little bit longer in one direction than another. It's an ellipse. And they couldn't tell that before they could do these kind of calculations. If it was all about calculations, we would forget about logarithms because we can do the calculations now. We do have computers and calculators and electricity, and we can do them without resorting to logarithms. But logarithmic functions, in fact, come up in science, right? They come up a fair amount. They come up in calculus. Doing pretty basic derivatives and integrals and calculus, things that you will do in Algebra 2, let's say 2 years from now, you will be doing things in calculus where logarithms just kind of occur. They just kind of occur out of nowhere. you didn't like start with it. You were doing something else, had nothing to do with it, and then all of a sudden you got a logarithm. So they're useful functions when you're doing math and science at a higher level. But why were they started? They were started because of calculations at a time when they needed something to simplify a more difficult operation of multiplication into a more simple operation of addition.